And we're going to talk about computer science education for all kids with a focus on kids with disabilities and those at risk for academic failure. So essentially what we're going to talk about today is what is computer science? What does it mean when we say computer science for all? We're also going to talk about the specific challenges that students with disabilities are going to face when they're in computer science education environments, and then about approaches that we can use to support them as they are learning computer science education. So firstly, what is computer science? Computer science is really about recognizing problems that can be solved in a computational way. What kind of problems can be best solved through a computer? And then what are computational approaches that we can use to solve those problems? And there are a lot of misconceptions about what computer science is. And so there's a list here that include a lot of different things that computer scientists do. Beyond just computer programming, they're iteratively problem solving. They're collaborating with their peers. They're communicating with other computer programmers and with their clients. They're working with both hardware, for example, the cell phones, as well as software, so those apps on the cell phones. And they're using logic and creativity. Computing and computer science is actually everywhere. In fact, only about half of all computing jobs are in tech companies. The majority of computing jobs are in fields such as architecture, in medicine, in music, in education. So think about using data analytics to understand how well students are learning, or think about using animations in movies or learning to use video games for learning. All of those require computing. So if we think about computing from this perspective, then we start to think about computer science as foundational knowledge, along with the other STEM fields, along with science, technology, engineering, and mathematics. We think about computing as part of that, and we think about it as part of the T in STEM. If we think about computer science being everywhere, then we have to start to think about how is it that we're going to teach kids how to learn computer programming, and this is where computer science education is going to fit in. In fact, right now, there are more and more K-12 educational opportunities around computing that are being developed. And what they're doing is that they're teaching children to create technology, not just to be consumers of technology. So right here you see a bunch of different icons for different computing software, everything from Scratch, which we'll talk about in a moment, that we're using in our projects, and code.org, which are very specific to learning computing, to programs that actually teach computing within the context of other STEM areas. So Project Guts teaches computing within the context of science, and Codesters and Bootstrap teach computing within the context of mathematics. If we start to think about computer science education, the next step is to think about how do we provide that education to a broad range of learners. So recently, in January of 2016, the White House announced an initiative called Computer Science for All, where they urged Congress to allocate additional funding to computer science education. They allocated money through the National Science Foundation to do more research and do more teacher preparation for computer science education. And then recently, in April of 2016, 26 governors, both Democrats and Republicans, signed a petition to urge Congress to do the same. Now, states and school districts are also creating their own opportunities in addition to these national initiatives. So states like New York City have decided they're going to have big computer science for all initiatives. And school districts, including our local one here in Champaign, Unit 4, have created different computing experiences both at the elementary, middle school, and high school level to provide computer science experiences with the purpose of computer science for all, so that these are not things that are just provided as enrichment opportunities for students and aren't just provided to kids who have the means to be able to afford after-school programs. One of the first things we need to do is think about misconceptions about computer science. And so one of the things that a lot of people think is that computer science is for geeky guys who sit alone in their basements and they do computer programming on their own. And they also think that you have to be a genius in order to do computer science. The message that we're sending to both teachers and to students is that computer science is really for everybody. And in fact, when you have a diverse group of people working together, on programs, those programs are actually better. More people buy those programs, they reach a wider audiences, and so it actually helps to have a very diverse group of people working together. The other thing to know is that you don't have to be a genius to do computer programming. If you can do basic arithmetic and a little bit of algebra, you can do computer programming. And so once we get through these misconceptions and we can start opening the doors to providing that kind of instruction to kids. Why are we focused on computing? There are two main arguments. One is the job argument, which you'll see in the next slide as well. According to the U.S. Department of Labor Statistics, by the year 2020, which is actually just around the corner, there are going to be 1 million computing jobs. And only about 30 of them are going to be able to be filled at the current rate that we're preparing folks. But then beyond the jobs argument, we actually have this argument that says that we're teaching kids real-world application of mathematics. We're teaching kids to persevere through difficult challenges. We're teaching them persistence and collaboration through computing. And so there's a pedagogical reason for doing so. And there's also an equity reason, because we know that kids who don't have access to computing in the earlier grades are much less likely to walk through those doors that will allow them opportunities in the future. This is a slide from code.org that shows those statistics in a more graphical manner. What you can see here is in that pie chart, which shows all the science, technology, engineering, and mathematics jobs in the year 2020, about 60% of those jobs are going to have something to do with computing. And then the graph below is showing that of those 1 million unfilled jobs in computing, we're really only preparing a small percentage of those of people to fill those positions.